As I mentioned in the first talk in this session, we always have to estimate the completeness of the OpenStreetMap buildings for what we were doing. Of course, it's interesting because OpenStreetMap holds now 560 plus million buildings, but it is still not all of them, and we need to know how to deal with incompleteness, and we need to detect the incompleteness. This is what we're doing here. We're using this remote sensing data. It is the global human settlement layer that I mentioned before. So the question is really, what is the status quo, and also to track the status quo. And we also want to have an estimation of the built area per land unit. Maybe if you remember on the talk before, the issue is that if we have no information, we take this measure of the built area per unit land and put virtual buildings there to cover the people and account for them. So the goals of our endeavor here was we wanted to be worldwide, like with our exposure model. We wanted to provide it in high resolution, again, for these quad-tree level 18 tiles, 100 meters at least. And we want to be dynamic so that if people start working on things, that there is an feedback that this thing happens. And you know, we have 5 million buildings being added to OpenStreetMap roughly per month. This is around 150,000 per day or 2 per second while we're sitting here. And so every time we try to update our completeness assessment. So the way we're doing it, because there is not really a ground truth. If there were a ground truth, we wouldn't have to use OpenStreetMap buildings. We would use the ground truth buildings. So we use Earth observation data, namely the global human settlement layer. And we use the version of 2022 because it is very recent. It has a high resolution, 10 by 10 meters. And it has also a very distinguishing characterization of all the pixels that it has, telling us about building height, or let's say height of the built area, if it's roads or buildings, etc. So what we're doing is we are vectorizing these pixels, put them onto the globe. And this is already a pretty huge database now, but the problem is, how do you estimate the completeness? You have these pixels and you have buildings. So like in the other case, we put a grid on top of this. But in this case, we want to save a little bit on the grid nodes, because if we use the level 18 grid globally, we get 68 billion tiles. But most of them don't really have too much information. So we actually start from the largest tiles, level 1, so 4 level 1 tiles. We always look, is there built area in this tile? And if we have built area in this tile, then we subdivide it to a level 2 or level 3, etc. Here's a way to show this. I don't know what level this is. I think it's level 16. And then we know in these tiles we have built area, either buildings or the global human settlement layer. And then these tiles we subdivide into smaller ones. And then we check again, and then we get the small ones. These are our target tiles, the 100 times 100 meters. So this is the discretization on which we initially want to do the completeness assessment. And this is what this looks here. This is the global human settlement layer, the built area for the city of Maastricht, and these are the OpenStreetMap buildings. And then we can put the grid on top. Now you see our discretization levels. And here is the assessment in a ratio of OpenStreetMap compared to global human settlement layer. And then you see the darker it is, the more complete we think this is. Now there are limitations to this approach. Please. Yes, no problem. There are limitations to this approach. First one is that the level 18 tiles, because we use a Mercator projection, in Spitsbergen they're only 30 meters big, while around the equator they go to 150, 180 meters. So we're not comparing like the same thing, but for technical reasons using the quad tree is extremely efficient and helpful. The second limitation is the GHSL accuracy. So you see here the pixels of GHSL but it's pretty obvious from the underlying satellite imagery that there is no building. There's not even built area. So something, rocks or anything else, has created a signature in the remote sensing data that was interpreted automatically as buildings. So this is not very helpful. And why this is so small, I don't know. It used to be bigger. The message on this tiny little icon was that for every building, we associate the building to a quad tile by its centroid. So we plan to extend this, that we actually chop the building footprint polygon by the quad tiles. But you have to consider that we have 560 million buildings. We have, of these 68 billion tiles that contain built area or buildings, we're still remaining with 370 million tiles. So we have many, and then doing all of these geometrical operations is quite costly. So we said, okay, we start with the centroid. However, there are problems when you have a very large building. This building may, cover a couple of tiles, and only in the tile where the centroid is, we actually account for the size of the building. So these are limitations, but I'd say, of course, on a tiny perspective, our assessment may not be correct, but on a big picture, it usually is very well done. So now we need to calibrate this, because the global human settlement layer is always in these 10 by 10 meter pixels, but the building footprints are sort of more precise and in general smaller. So we cannot say a tile is complete if the footprint size of the buildings match the polygon size of the global human settlement layer. So what we've done, a couple of things. We first looked into complete countries to see, like Netherlands, where we know we have all the buildings, how does this compare to the global human settlement layer? And then we were also doing, which is not mentioned here, unfortunately, because, as I said, it's not on my slides. We've done this manual assessment of 1,000 random quad keys, but we also done a manual assessment of all quad keys in the Attica regions, this where the city of Athens is, and some islands, etc. So this we've done manually, and we've chosen Attica for the reason that it has a big city in it, and this city is partially complete, partially incomplete. We have kind of desertous area on these kind of very unvegetated islands. We have forests, we have coasts, everything is in there. So that gives us a pretty good overview of things that we could see. We should actually do this in the desertous areas in South America or in the tropical rainforest. We should do the same thing there, but we haven't done yet. And we do a binary and a ratio assessment. So first is an interesting picture here, I think. We're just comparing on the 100 by 100 meter tiles, and we used 100 by 100 meters because we were not showing it to GeoGeeks. So for us, this is the level 18 quad key that we use here. And so we have about 70% in the complete countries where all the buildings are. In 70% of the tiles, we have global human settlement layer and buildings on top. In about 5 to 10% of the tiles, we actually have buildings, but global human settlement layer said there's nothing. And we have about 25% of the tiles where global human settlement layer says there should be buildings, but there are not. Like this one tile that I showed before, where the global human settlement layer was on top of purely vegetation. And interestingly here is that if you compare the complete countries, you see a very similar pattern everywhere. And the moment you go to an incomplete country, that thing looks very, very different. Now you could say, okay, well, these 100 by 100 meters thing, that's a little bit too precise. We've done the same thing on 1 by 1 kilometer or level 15 tile. And you see again, very, very similar picture for the complete countries. These kind of corner cases are shrinking a little bit, and in favor of the number of tiles that contain both global human settlement layer and buildings. But again, for Greece, very, very different. That's a totally different picture. So this is sort of our binary assessment. If we go into the ratio assessment, here's the Netherlands again, as you know, complete. This is the percentage of the OSM coverage on top of the global human settlement layer, and you see the bulk of it is somewhere between 25 and maybe 60%, and we have all the outliers of OpenStreetMap being bigger than global human settlement layer. And this up here may actually be these buildings that I mentioned before, where we only take the center and are just covering the entire thing. So, and these here are the problematic tiles where we have low to none coverage, and these we consider incomplete. And again, if we compare this with other countries, Austria, Netherlands, France, very similar picture. This kind of range of percentage in the ratios is the same. In Greece, boom, here's the incompleteness. It sticks out as the top tile here. The manual assessment was done partially with MapSwipe that we have extended with the group in Heidelberg to do completeness, but also on a little self-made web platform that unfortunately we never got to the point that it really works so well that we could release it or show it to others. You could just screw up everything if you don't know what you're doing. But here you see this is considered an incomplete tile. We see a building, no global human settlement, no building footprint on top. Here are the building footprints that we see. This is a nicely complete tile. Every building that was in this tile is covered. And then we have the empty tiles that we also consider. There's no global human settlement layer. There's no building. There's just nothing. This is empty. Here are a bit of the ratios so that you get a feeling of why we decided to take 0.25 as a somewhat conservative estimate of completeness. So if we are ratio 0.01, I don't know, can you see this kind of shady? That's the global human settlement layer, so slightly tilted. You see this is all shaded here correctly, so there are buildings, but we only have a handful of buildings. Or here the same thing, this one is completely missing. Here's one, and so this is ratio of 0.1, ratio of 0.2 is the same thing, not enough buildings. And then from here on, you see we have all the buildings, but the global human settlement layer is much bigger, and here everywhere the same thing. So how do we do this? So we're doing this for the entire world. We have computed it once as a sort of a starting point, and then as with the exposure model that I introduced before, because this is really just a part of the whole processing chain for the exposure data, every 60 minutes we pull all the new buildings, and for every building we check in which tile is it, and then we estimate the completeness of the tile in new. Here's a case study of Athens. I mentioned it because we've done this manually, but this is now to show how the automatic processing works here. These are the buildings that we have in Athens, but if you compare to the built area, let's go back, you see that this is this dividing line. Oopsie daisy. Here's the dividing line, and this part of Athens is basically not mapped yet, or not, the buildings are not entered. And then we can do now the build area from global human settlement layer either on this level 15 1 by 1K or level 18 100 meter grid, and then from that one we estimate the completeness. This is sort of the bigger completeness where we aggregate more. This is the fine gray completeness, and if I add the buildings on top, then you can really see at least the green patches are very well matching with the building data that we have. So now it's to finish and wrap up, let's look a little bit onto the global scale. This is the global world completeness map. So the darker, the more complete it is. But as we said, we expect around 25% of things to be complete. But you see, you have centers of activity, unsurprisingly, Europe. And here's a relative, here's sort of the high score. So Norway, Denmark, Netherlands have the highest percentage of complete tiles within their country. And then there are some that are very poorly mapped so far. So about the goals, we did achieve them in a way. We have a worldwide system. It's updating every minute. We have it on a super high resolution, and it is dynamic, as I said. But we also have limitations, something that maybe we should even have a bigger discussion about this. And this is the question of accuracy versus precision or resolution here. You know, if you go too small, then you are very precise, but the accuracy is going to fade away because the buildings don't match with these little tiles. If you go too big, then you may be really catching the proportions right, but you're losing the precision. You don't know exactly where you should have looked. So, where are we in terms of building completeness overall? So we have made some assessment based on the number of tiles that are already complete compared to the incomplete tiles. We have made assessments based on the number of buildings per country compared to the population data, and we are coming to the conclusion that we are roughly 30% on the way. And I think this link is wrong. We are changing it right now. Leave the new away, and I'm not sure if the new website is on. If the website is bluish, then it's new. If it's grayish, then it's old. Lars, my colleague, wanted to do this yesterday. Apparently something went wrong. I don't know.
There's no new, I think.
There's no new? This one, yeah.
Blue one.
Is this with new or without new?
Without new.
Yeah, so everything is cool. Just forget the new. Okay. All right. That was it. Questions? Thank you.